Video coverage of the 27th JCT Traffic Signal Symposium is brought to you by Highways News, thanks to our sponsors AGD Intelligent Traffic Systems, Clearview Intelligence, PTV Group, Message Maker Displays, Smart Video and Sensing, SRL and TRL.
Good afternoon, everyone. I hope this is the last presentation, so I hope it's of interest. So Starling Technologies, as already mentioned, is a new business distributed across the UK, doing work in the UK and also elsewhere. We have 3 products, and we're doing a lot of work in France and Canada with Colas, with a product called Control. But I'm here to talk about the work that we are doing with Cambridgeshire, Greater Cambridge Partnership and the Cambridgeshire County Council on a trial of a product called Starling Detector. So Starling is very much focused on looking at the safety of pedestrians and cyclists. We use a bunch of technologies, some of them that you've seen throughout this session, computer vision, machine learning, or bits of AI to enable that to happen. So I should also say that this is part 1, and I'm hoping part 2 will come next year. So this is really an introduction to the trial that we're doing with Cambridgeshire in Cambridge that we just started last month. So we are working on a site in the city centre, East Road. It's outside of the university, Ruskin Angular University, which is on one of the main thoroughfares into the city centre and becomes extremely busy at timetabled, scheduled periods, but also significant amounts of infrequent numbers of students and also people walking into the city centre. It is very much identified by the council, or both councils, as one of the travel corridors for pedestrians and cycles. So one of the problems we're looking at is just the significant levels of high demand from pedestrians, and to be able to reduce the impact of pedestrians and other users in and around the pavements, the crossing and the roads during those times. So we have our own detector. It's currently sitting alongside the AGD, above the signal head, looking down into one direction of the street and the landscape, and another sensor looking in the opposite direction. So the two sensors can see the full landscape of the road. Now I'm going to unpick this a little bit later on. And so I just want to start defining what we are looking to do. There is a significant unpredictable pedestrian load that comes 95% of the time, and these are it's anecdotal from the councils, but 95% the existing setup of the crossing works fine under the load that comes from pedestrians, but there is 5% of the time that the pavements get overloaded, and a human emotion kicks into play, which is impatience. And with impatience comes unsafe behaviour. And that's when the sidewalks get loaded and people are kind of itching to move and will either cross when during the red phase, or simply just walk out and turn into, I understand that this is not a recognised term, but turn into a jaywalker, turning to a non-compliant pedestrian. And so the consequences of this, all of this behaviour, is the crowded sidewalks, long dwell times, and then you start looking at what's important for this kind of change in cities. You're just wanting to kind of reduce exposure to different types of environmental conditions. And so our task using Detector is to reduce those pedestrian delays. And we do this by detecting and specifying and prioritizing user types. So this problem, and this is where, please be nice with me at this point, because this is very much your domain, and as I was pointed, I am new to this area. But historically, this issue has been tackled through the wardened control, which is part of the Topaz 250. It's an appendix that allows you to extend the green light, and also the fixed times that can be programmed into the controller. So again, you know when peak times are going. And if you look back, there's also TRL's volume-sensitive puffin that they tried back in the 90s to kind of tackle this volume-sensitive issues. And really where we wanted to come in was looking at how can you dynamically control, and I use that word very lightly, control the pedestrian flow, particularly at those unknown periods. And it could be not the kind of coming out of class, but it could be just when large numbers are moving in and around the university, as well as other external events such as football matches or just people going into town. So we have these two sensors. Our sensors have a wide view. So that means they're viewing, one sensor is viewing this whole landscape. So we've got two pavements. So we can see the approach of all pavement users. We can see across the crossing, and we can also see the curbside. So our detection zones around the crossing on both sides allow two sensors to see significant amount, and so can see people objects waiting and objects approaching. So this is how we're thinking about interventions around this problem, which is looking at how do we create longer pedestrian greens and reduce the fixed green periods. And we're looking at how Starling Detector can enable that to happen. And so we have created, we're right at the beginning of our trial. The first is collecting a lot of as-is data. So kind of looking for a long period of time, a 4-week period, of what is happening and being able to collect the data from that site to be able to kind of move it into stage 2, which was when we can then take the data and compare it to the information that's coming out of the UT Ski and Scoot, and also compare it to independent confirmation of slices of video that will be done independently confirmed of our analysis and the accuracy of what we are doing. And then from that, to take that into stage 3, which is where we are looking to intervene into the controller to dynamically, assess and alter the timings to the timings of the demand cycles. And one of the ways that we are looking to do this is by identifying user types. So for this site, the customer is looking to identify through our detection system user types. Now, an example of that might be a parent with a buggy. If we detect a parent with a buggy within our landscape, our detection zone, and they are coming, and they're either coming towards or at curbside, we can then make a decision, or the customer can then make a decision of what to do. For example, extend the green light. So in these two examples of the sensors looking in both directions, the detection, what you can see here, you can see various things being detected, and you can see it. And the system kind of displaying what is being detected. I'm going to show a little bit more video so you can see it in action. And so again, this is kind of looking at people, and what's interesting on the right-hand side of one, and this is purposely done, is because we're looking at room and over kind of too many people on the pavement, the right-hand one becomes really important, and it is a detection that we have increasingly found at this crossing, which is pedestrians pushing a bike. So the size and the area that those user types take then can influence the overloading of the sidewalk. So these are just examples of user types that we are discovering as we are doing this initial phase. So this is just a short video of one of the I think it's the north-facing detector, and you can see the cars and the people approaching or leaving, and the system in this example is indicating how many people are particularly focused in on at the curbside and approaching both the crossing from vehicles' point of view as well as pavement users' point of view. So Starling detector, we're Towpass compliant, and of course part of discussions with around the Towpass for the forthcoming richer detection interface. So we're kind of moving towards, this is all very early. We're at the early stage of the trial. The first phase, stage one, was done during August. We're actually going to take it further into September, because clearly August, yes, there are students around, and yes, the citizens of Cambridge are using this travel corridor, but really once September comes, that's when the majority of the students are going to be. So we're going to extend that kind of capture as is capture period into September, and then start moving into phase two, kind of looking at the comparing of the data coming out of scooter news, out of the crossing. So one of the other products is Starling Intelligence, and Starling Intelligence is a behavioural analytics system. We use this for surveys, but we can attach it to detector, and that provides behavioural analysis and data of what is happening at that crossing. So in reality, Starling Detector on this site is doing two things. It's dealing with the prioritisation and intervention at this crossing, but it's also providing behavioural data for the local authorities. And I'm just going to give you a bit of a glimpse into some data. I am not touching on count. So I'm not telling you at this point, when I'm not telling about how many people, how many cyclists. That's a given. But what we have then approached it is within this period, we looked at how many times 3 scenarios were activated. And that was all measured in minutes, and that was how many times a pedestrian was on a crossing, how many times a pedestrian was waiting at curbside to cross, and how much time of approach, does a vehicle approach the crossing. And during that 7-day period, this is the analysis that comes out of it. Now, what's interesting about this is it starts to give you a really interesting insight into not just the numbers, but how that crossing is being used. And our interface also allows the data to be cut by day or night, by time, by day. So you get a really interesting insight into both the types of people that are being used and also how it's being used. And this is just one example of how Starling Intelligence is kind of presenting behavioral data and usage of a site back to the customers. So, as I mentioned, this is part one. We have just started this. Really, I want to present this. It chimes with other work that other companies, excellent companies out there have exhibited and trials that have been done. And also just to get your feedback on it. Of course, there is a white paper that is unfortunately not part of your packs. It has much more detail around what we are doing, so please come and see us. We are the only company that is still standing outside because we're in here. So we're easily found. Yeah. So thank you very much. Can I just
say that we will be making that paper available for download along with all the other papers in about a month's time. And I'd like to just, I know the chair's going to, thank you very much, Andrew, for stepping in very, very late in the programme. Sorry we couldn't get you into the printed programme, but you've been very welcome. Thank you.
Thank you.
Okay. Not a sea of hands up at the moment, but I think, you know, we're seeing that, if we can have a microphone over there, please. We're seeing that because of the changes in the prioritisation of different users, so, you know, pedestrians and cyclists, etc., at the top of the tree now, it's much more important to be able to actually have meaningful data about those users, and that's something that we don't really have. You know, Scoot for some time has had the capability to use a sort of volumetric approximation of the numbers of users to be able to do some things with. But another element really is, as Scoot has sort of network information data about vehicular traffic, actually to take this on another step, to have that information about the numbers of pedestrians and cyclists going on to the next site would also be useful.
It's not, for us, it's not about numbers. Numbers counting is relatively straightforward. What we are interested in is behaviour. And being able to turn that behaviour into metrics so that then you can supply your stakeholders with that information. It's more than just simple count. From our perspective, it's how it's being used.
Yes, yes.
Sorry.
No, I think that is a very good point, definitely. Yeah.
Thank you. Andrew, I don't know if you were here for the Mover User Group on Tuesday, and I don't know how many people in the room were, apart from Mark Crabtree, where there was a paper looking at volumetric detection on the approaches to a crossing and a discussion about the effective radius in which volumetric information was being gathered. What I saw there in those images in that video of that field of view that you've got.
So although I wasn't at that session, I had a long conversation with the author, Chris, the other night. And actually what we both agreed was that what's really interesting is that these types of new solutions shouldn't necessarily just parachute themselves in. And actually, Chris and I had a long conversation about how we bring the two together so that Mover, the configuration that Chris has proposed through Mover, can work in hand with the extension of the detection, and of course, because of our machine learning, the prediction element that comes out through time, and it should be a solution that is knitted together rather than sits on top and ignores each other.
Thank you.
Okay, thank you. So if we could thank Andrew and our other speakers as well.